Good day, students. Good day, viewers around the world. If you're watching me for the first time, my name is Aneke Victor, a mathematics and a further mathematics teacher in one of the best schools in Port Harcourt, and that's Nick Angels International School. We understand the effect of the pandemic, but I can assure you that medical experts are doing everything possible to stem the trend. And in no distant time, everything is going to be normal again. We can only advise that you take precautionary measures during this period, like washing your hands, wearing a face mask, and observe social distancing. For SS2 students that are sitting at home now, we wish to continue our scheme of work for the third term. And the first topic in your scheme of work is circle geometry. And I've written the topic here on the board. And my aim is to make you understand, first of all, the meaning of a circle and its properties, and then circle theorems and their application. Meaning of a circle first and its properties, then circle theorems and their application. I want you to get your maths notes and write down the meaning that I'm going to be writing on the board. Please, I want this to be a bit interactive. I want a situation where in our comment section, you can go there and make your observations. And after this class, assignments and classworks will be given. And I want you to participate properly. First things first, I'm going to write down the meaning of a circle on the board, so you can write it down in your notes as you get it. Meaning of a circle. A circle is the locus of all points equidistant from a fixed point. As the center. So I'd like you to write this down. A circle is the locus of all points equidistant from a fixed point. And of course we know that that fixed point is the center of the circle. So we have to go ahead and understand some features or properties of a circle. The first property we'll be looking at is a radius. The radius is the first thing we're going to be looking at in a circle. So I have circles drawn here, and the center of the circles are dotted. So first things first is to know that the radius of a circle is a line drawn from the center of the circle to any part of the circumference of the circle. The radius of a circle is a line drawn from the center of the circle to any part of the circumference. The radius can as well go this way or that way, anywhere, provided it comes from the center of the circle to any part of the circumference. That is the radius. Another feature of a circle is the diameter. Please, you have to also write this one down, that the diameter of a circle is a line drawn from any point of the circumference to another, and the line must cross the center of the circle. Diameter, I say again, is a line drawn from any point of the circumference of the circle to another point in the circumference, which crosses the center of the circle. So I draw my diameter from this point, crossing the center of the circle to this other end, and that is the diameter of the circle. So I write it down here as my diameter. This was my radius, and that is my diameter. Another property of a circle that we are going to be looking at is a chord. A chord is very similar to the diameter of a circle, but the major difference is that the chord does not cross the center of the circle. So I draw my chord from this point of the circumference to another part without touching the center of the circle. So I can write this down as my chord. These are certain properties we have to know of a circle before we can successfully learn the circle geometry. We've been able to establish 3 properties of a circle. We can just take that again. We said that the radius is a line drawn from the center of the circle to any point in the circumference. The diameter is that one drawn from any point in the circumference to another point which crosses the center of the circle. A chord, we said, is a line drawn from one point of the circumference to another point without touching the center of the circle. The 4th property we'll be looking at is a sector. A sector is the area bounded by 2 radii. I say the sector is the area bounded by 2 radii. This is the radius, and this is another radius. The area which these radii cover is known as a sector. Of course, we know this sector as the minor sector, while this section of the circle is known as the major sector. Other properties of a circle can be drawn in this one. We've been able to say what a chord is. I want to also tell you that a chord cuts a circle into 2 segments. The major segment and the minor segment. So you can have a circle cut into 2, and if you don't cut it exactly into half like the diameter did here, you'll be cutting it into 2 segments. One is called the major segment and the other is called the minor segment. Another property of a circle is the tangent. The tangent is a line which is drawn to touch only one point in the circumference of the circle. So the tangent can be drawn in any of these circles. The tangent can be drawn past this, and the line is called a tangent. I take that again. A tangent is a line drawn to touch only one point in the circumference of a circle. You can write that down. Another property that I will mention to you is the secant. The secant is very similar to a chord, but the secant is drawn to cut across the circle. So I'm going to draw my line to cut across the circle. If I had started here and stopped here, it would have been called a chord. But because I went past it, that line is called a secant. So these are the properties of a circle that you need to know first to understand circle geometry. To understand circle geometry. To understand circle theorems and their applications. So I'd like you to understand that one very, very well. And I also like to see it in your notes when school resumes properly. To screenshot these notes and send to my email address or my WhatsApp number, which will be given to you at the end of this class. Having known those properties of the circle, we now have to go into the circle theorems, because it is our knowledge of the properties of the circle that will help us with our circle theorems. We have so many circle theorems. We have 5, 6, 7 of them, as the case may be. But we might be handling 3 of them today. Maybe in our next class we'll handle the remaining. So the first circle theorem that I'll be writing on the board is a line drawn from the center of a circle to bisect a chord is at right angle to the chord. So I'll just read that to you. A line drawn from the center of a circle to bisect a chord is at right angle to the chord. So this can be shown in one of our circles. We said any line you draw from the center of a circle to bisect a chord, and that line will make a 90-degree with the chord. So I'm going to draw a line from this center of the circle, but first of all I draw my chord. So if this chord is drawn this way, and I draw a line from here to this point to bisect it. To bisect a line means to cut it into 2 equal halves. So they are saying this is 10 centimeters, this is going to be 5, and this will be 5. If I say this is 20 centimeters, and this is going to be 10, and this will be 10. You can try this at home. But if you're trying this, you have to draw a perfect circle with a protractor and your compass. So if you draw that, you can make a chord, any chord. The chord must not face this direction. The chord can even face this part, provided you know the length of your chord. If you draw any line from the center of the circle to bisect that chord and the line drawn will always be at 90 degrees to each other. So if I draw a line from here to this point and I bisect this chord, the angle formed here will always be at 90 degrees. Similarly, if I draw it on this other circle, I draw a line to this point to bisect it. The angle formed here will always be in 90 degrees. So this angle formed here. Now, questions around this particular theorem are always designed to form a right-angled triangle. Because obviously, if I include the radius of the circle from the center to any point in the circumference, I have ended up forming a right-angled triangle. Yes, I could have drawn this radius from the center to any part, but I chose to draw it to this end so that you can see the shape that I'm about to form. I can as well draw from the center of the circle to this part. It's going to be like this. And I've also formed another right-angled triangle. So if we can know this distance and we know the length of the chord, then we can find the radius of the circle. So if we also know the radius of the circle and the length of the chord, we can as well get the distance from the center of the circle to the chord. So I'm going to write down a question on the board to support the usage of this theorem. So I have a question here to support the first theorem which we have written on the board earlier. The question was gotten from the New General Maths textbook for SS2 on page 27. That's the New General Maths textbook on page 27. That's where you have the question I wrote down on the board. And that's question number 1. The radius of a circle is 10 centimeters. The length of a chord is 16 centimeters. Calculate the distance of the chord from the center of the circle. When I see a question like this, I draw my circle so that I can impute the information given to me. The first thing I have to draw is the length of the chord. So I draw my chord this long, and I label that the length of the chord is 16 centimeters. Another information I was given here is that the radius of the circle is 10 centimeters. Like I said earlier, I can as well draw my radius from this center to any point on this path. But I know that I'm going to form a right angle triangle. So my preference is to draw it this way, so that it comes from the center of the circle to touch one end of the chord. And the radius of that circle was given to me as 10 centimeters. So their aim, or the question says that we should find the distance of the chord from the center of the circle. So they're actually looking for the distance from this center down to this chord. And we had said earlier that the center of the circle, if a line is drawn from it to bisect a chord, it is at right angles to it. So, and it bisects this chord, it means that it cuts this chord into 8 cm and 8 centimeters. So what I should do is to extract this right angle triangle elsewhere, and then I will be able to find the distance from the center of the circle to the chord. So on this part of the board, I put my solution, and then I extract my diagram. We had said this part is 10 centimeters, so this is written as 10 centimeters, while this other side is 8 centimeters, so this is 8 centimeters. We are interested in finding the distance from the center to one end of the chord. Of course, we know that it formed a right angle triangle. When I have a question coming from a right angled triangle, one theorem comes to my mind, and that is the Pythagoras theorem. The theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. The square of the hypotenuse is equal to the square of this and this, equal to the sum of the squares of this and this. So I say by Pythagoras theorem, c squared is equal to a squared plus b squared. We can always use this when we don't have letterings. We can always use this Pythagoras theorem when we don't have letterings for the triangle. So the c is the hypotenuse. The hypotenuse is the part facing the right angled side, the 90-degree side rather. So c is my 10, and that's the longest side of this triangle. So 10 squared is equal to 8 can be any of the sides. So 8 can be 8 squared, while x will become b. So I have x squared. At the end of the day, 10 squared is 100, meaning 10 times 10. 8 squared is 64 plus x squared. I have to take like terms in order to find x. So 100 will subtract 64. So 100 minus 64 is equal to x squared. 100 minus 64 is 36. Then confirm that with the calculator. We have now that 36 is equal to x squared. Then the square root of 36 becomes equal to x. And the square root of 36 is 6 centimeters. Is 6 centimeters. It shows that the distance of the chord from the center of the circle is 6 centimeters. We have found what they want from us in the question. So we can say, therefore, distance of the chord from the center of the circle is 6 centimeters. We have answered that question. So I'm going to write another question on the board to continue with the circle theorem 1 that we have written earlier. Okay, I have written the second question on the board, and this one says an isosceles triangle ABC has its vertices on the circle. If AB is 13 centimeters, BC is 13 centimeters as well, and AC is 10 centimeters. Calculate A, the height BM of the triangle, and B, the radius of the circle to the nearest whole centimeters. I take that again. An isosceles triangle ABC has its vertices on the circle. If AB is 13, BC is 13, and AC is 10, calculate A, the height BM of the triangle, and B, the radius of the circle to the nearest whole centimeters. Now, first of all, I have to understand what an isosceles triangle is. An isosceles triangle is a kind of triangle that has two equal sides, and the base angle of an isosceles triangle are equal. But they said it has its vertices touch the circumference of the circle. So I'm going to draw the isosceles triangle to touch the circle that I have on the board. This is the center of the circle. If I draw a triangle this way, another line this way, and perhaps the last of it on this part, I've been able to draw a triangle. Now from the information given here, it says that AB is 13 and this is 13. So I like these two parts to be my equal side. It means that this is A, this is B, and this is C. This is the 13 centimeters, this is another 13 centimeters, and this is 10 centimeters. It fits the information given to me in the question. So what they're asking me to find is the height of the triangle. The height BM of the triangle, meaning a line that is drawn from B to cut this to a point here. So this is where my M will be. So if I draw a line, to cut the center, this is the height in question that they want us to find. That height is a line that divides the isosceles triangle into two equal halves. That line is called a line of symmetry. From here, I can be able to get this height if I understand that this height cuts this base AC into two equal halves. It bisects it. Because we had said in theorem 1 that a line drawn from the center of a circle down to the chord divides it, it is at right angle to it, and it bisects it. Even though we drew this line from B and down to M, it still crossed the center of the circle. So it goes to show that this is 5 centimeters and this is another 5 centimeters. And the angle formed at M here is 90 degrees. So to find the height A, I have to write my solution, and then I extract this diagram. It looks like this. This is 13. This is H, which is the BM that I'm asked to find, and this is my A. So we're asked to find BM of this triangle. So this is also 5 centimeters as well. This is 13 centimeters. So in order for me to get H, I have to use the same Pythagoras theorem that we have used before, because this is still a right angled triangle. So I write by Pythagoras theorem, c squared is equal to a squared plus b squared. This is conventional for all triangles that don't have letterings. But for this particular triangle, we have letterings. We have our A and B to be C, because the length of the line, the length of the hypotenuse was lettered as AB. So in place of C, I should be writing AB squared is equal to, A becomes any of the other two parts, we've said that before, AM squared, I write that, AM squared plus BM squared. So AB squared is equal to AM squared plus BM squared. That's what the Pythagoras theorem says. AB is 13. This is what we have here as 13 squared. AM is 5. So I have it as 5 squared. And BM is what we are looking for. So we leave it as BM squared. 13 squared is the same thing as 13 times 13. And that will give us 169. 5 squared is the same as 5 times 5, and that will give us 25. I have my BM squared. 25 goes over to make 169 as taking on like terms, and it becomes minus. If you subtract 25 from 169, you're going to get a 144, and that's equal to BM squared. So BM becomes equal to the square root of 144, and that's equal to 12. So we can say that BM is equal to 12 centimeters. BM, which is the height of the triangle, has been found to be equal to 12 centimeters. So we have just found the solution to the first part of the question, which says we should find the height of the triangle. So we have found that part, and we're left with finding the radius of the circle to the nearest whole centimeters. If you can observe, we were not given the radius of the circle. We were only told the length of the sides of the isosceles triangle. With the information we were given, we were able to find the height of the triangle. The height is going to help us in finding the radius of the triangle. Okay. The height has been found to be 12 centimeters. The height is going to aid us in finding the radius of the circle. So on this part, I can write down the height here to be 12. This is 12 centimeters. We understand that the radius of the circle is a line drawn from the center of the circle to any part of the circle. So from this part to this part can be labeled to be R. This part, this radius, the center of the circle, to this other part can be labeled to be R as well, because a line drawn from this center to any part is called radius. So this is the radius, this is the radius. But the length of this height is 12. Most people would have thought that if this is 12, then from this part to this part is 6. But no, because it would have been 6 if this line was drawn from this end down to this end. So we would have just divided 12 by 2 to get 6. But because this line was drawn from here to stop here, it would not be wise, or it would be incorrect, to divide 12 by 2 to get the radius, meaning that we don't know the radius. So this part is R, which is the radius, and this part is R. Then this part becomes 12 minus R. If the whole of this line is 12, and from this part to this part is R, it means that from this point to this point will be giving us 12 minus R. So I have this part to be 12 minus R, I have this part to be R, and I have this part to be 5. If you observe, I have been able to form a right angle triangle inside another triangle that was given. So if I extract that part, it is going to be drawn like this. This is a right angle triangle as well. I have one part to be 12 minus r. I have another part to be r, which is the hypotenuse, and I have this other part to be 5. With this, I can find the radius of the circle. The radius of the circle will be found using the same Pythagoras theorem, which says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we don't have letterings for this one, except students that would want to include a letter here as O, so that you can have it as OC and N. So you can as well include letters to make you understand it. If you have issues with including letters, you can use the conventional C squared being equal to A squared plus B squared. So I say by Pythagoras theorem, C squared is equal to A squared plus B squared. You must always be conscious of your C squared. It cannot just be any one of them. It has to be the line which is facing the 90-degree side, or the longest part of the triangle. So by Pythagoras theorem, C squared is equal to A squared plus B squared. You have to be conscious of which is your hypotenuse. It cannot just be any one of them. It has to be that line that is facing the 90-degree side, or the longest line in the triangle. So from here, my C is my R, so I write it as R squared. A can be any one of them. A, usually I prefer the value down here, that's 5 squared, and my B is 12 minus R. Because it's a binomial, I have to put the square in a bracket. So I just have to expand this, take like terms, and I'll get the answer. So R squared is equal to 25, because 5 squared is 5 times 5, plus the expansion of this one will be written as 12 minus R times another 12 minus R. So I have to be quick in expanding this one. I have R squared to be equal to 25 plus, in the expansion of this value will times these two values, and this other value will times this. So 12 times 12 will give us 144. 12 times R will give us a minus 12R. 12 times another R will give us minus 12R. Minus R times minus R will give us a plus R squared. So if I take all the R values to the left-hand side of the equation, this will become R squared, which is this R, minus this R squared. When 12R is coming over to this side, when minus 12R is coming over to this side, it turns plus. So it becomes plus 12R plus another 12R. So I have been able to take all the R terms to this other side. So I'm left with a 25 plus 144. If you notice, R squared will subtract R squared, and it will cancel out. So I'll be left with 12R plus 12R, and that's equal to 24R equals 24R will be equal to 25 plus 144. 25 plus 144 will give you 169. Then we divide both sides by 24. And you have that R is equal to 169 over 24. So you can do, you can use a calculator to check this. You're going to get a value that is approximately equal to 7 centimeters. You're going to get a 7.9 0.13 or thereabout. But by the time you approximate that value, you will get a 7 centimeters. We have been able to find the radius of this particular circle to be equal to 7 centimeters, and which satisfies the second part of the question, which says we should find the radius of the circle to the nearest whole centimeters. We're done with theorem 1. So we have the next circle theorem here written on the board. The second one says that the angle that an arc subtends at the center is twice that subtended at any part of the circumference. The angle that an arc subtends at the center is twice that subtended at any part of the circumference of the circle. It means that if a line or if two radii are drawn, it forms an arc. And the angle subtended here is 2 times the angle that will be formed by these points of the arc. If I draw a line from here to come to the center of the circle and back to this point, if I draw another line from this point and touch the circumference of the circle and back to this other point, the angle here is always 2 times the angle here. It means that if this angle is 100, the angle here will be 50. If this angle here is 80, the angle here will be 40. So the theorem states that if I have here the letter as A, O, and B, and I have this other side lettered as A, C, and B, angle AOB is equal to 2 times angle ACB. Angle AOB is 2 times angle AC and B. That is the second theorem. Of course, I can draw this theorem in another way. If I draw a line from one part of the circumference to the center of the circle and to another part, and I still label this as A, O, and B, the reflex of angle AOB is 2 times the angle that will be formed if I draw a line from this point down to this part and come from this part to this one. So the reflex angle of AOB is 2 times the angle, if this is labeled as C, as A, C, and B. I can also put this theorem in this format. I can say that reflex AOB is twice the angle formed at C. So reflex AOB is twice ACB. So I write it as reflex AOB is equal to 2 times angle AC and B. So this is the second theorem for today's class. And I have a very quick question here written on the board. The question gave us that a circle is drawn and 2 triangles are drawn inside of them. One is a smaller triangle here, and the other is a large one where the vertices of this triangle touch the circumference of the circle. The question here says calculate angle PRQ. Angle PRQ, meaning we should find this angle. With what we are given in this question, we were told that this angle here is 36. And how does this theorem help us to find this angle. The question is, how are we going to get this angle now that we know this theorem? The first thing I have to understand is that OP is the same thing as OQ because they are radii. This is the radius of the circle. We had said that the radius of the circle is a line drawn from the center to any part of the circumference. So OP is the same thing as OQ. For these two lengths to be equal, it means that the first triangle I have here is an isosceles triangle. And what property of an isosceles triangle do I know? I know that the base angle of an isosceles triangle are equal. So the first thing I have to write here is to know that line OP is equal to line OQ. The reason is because they are radii. And the property of that isosceles triangle is that this angle here is equal to this other angle. The base angle of an isosceles triangle are equal. Most people will not see it because I have another triangle here. We can easily eliminate these lines from our mind, then we can see the triangle. So knowing that this angle is equal to this angle, we can write that angle OQP is equal to OPQ. The reason is base angle of an isosceles. It is important to put your reasons when you're solving questions in circle geometry. So we've been able to know that OQP is equal to 36 degrees because we had said that this angle is equal to this angle. Remember, we had a line drawn to this point and back to this one. Now we are asked to find this angle. With these angles, we can get the third side of that particular triangle. We all know that the sum of angles in a triangle is equal to 180. So now that we know this part as 36 and this other part as 36, we can find this angle that is subtended here. So angle POQ is equal to 180 minus the sum of the other two angles. POQ is equal to 180 minus 36 plus 36. We're doing this because the sum of angles in a triangle is equal to 180. So we can say that 180 minus 36 plus 36 is 72. By the time you're done with this subtraction, we'll come up with an answer which is 108 degrees. Now we have just gotten that POQ is 108. So this part is 108. Now how am I going to get this part from this part? We had said earlier that the angle subtended at the center is twice that subtended at any part in the circumference. As this angle here is 2 times of this angle. I had said earlier that if this is 100, that makes this 50. If this is 80, makes this 40. Now, this 108 is related to this part according to this theorem. So, if I want to get PRQ, then I have to divide 108 by 2 to get PRQ. So I'll say PRQ is equal to 108 divided by 2. We can call this reason as center angle. So 108 divided by 2 is equal to 54 degrees. We have found PRQ to be 54. We were able to get it because of this theorem. From the knowledge of this theorem, we were able to get this part. We got this part from this part, but we couldn't have gotten this part if we hadn't known that this other angle is 36, because it's the base angles of an isosceles triangle. So that example is what will help us understand this particular theorem. Okay. That example we did then was able to make us understand the second theorem of the circle geometry. The third and final theorem for today is the opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Supplementary means that the angles add up to 180 degrees. Two angles are said to be supplementary when they add up to 180 degrees. And two angles are said to be complementary when they add up to 90 degrees. Now, if you draw a circle and you have a quadrilateral whose vertices touch the circumference of the circle, such a quadrilateral is said to be a cyclic quadrilateral. So from this theorem, if the angle formed here added to the angle formed here will always be 180 degrees. I urge you to try this at home. You can draw any circle and draw any four-sided figure. If you add the angles you get here and here, you will always come up with 180 degrees. Similarly, the angle formed here added to the angle formed here will also be 180 degrees. So if this is x and this is y, x plus y will always give us 180 degrees. And if this is a and if this is b, a plus b will also be equal to 180 degrees. This is what this theorem is saying. I've written an example on the board to help us understand this theorem. And the example is here. And it says that in the figure above, PQRS is a cyclic quadrilateral and SR is produced at D. So PQRS is a cyclic quadrilateral. It means that the four-sided figure is drawn inside of the circle where the vertices touch the circumference. The same SR is produced at T. So SR is extended until you get to a point that is labeled D. Angle QDR is given as 47, QDR is given as 47, and QPS is also given as 104. Calculate the size of DQR. How will this theorem help me find this angle? I have just said that opposite angles of a cyclic quadrilateral sum up to 180. Opposite angles of a cyclic quadrilateral sum up to 180. This angle plus this angle is 180, while this angle plus this angle is 180. Now if you look closely, this angle and this angle formed here should add up to 180 according to that theorem. So how to get this angle, I should get here first, here next, and then get the required part of the diagram. So to get this angle, I'll label it as QRS. So I write my solution. I start by writing that QRS is equal to 180 minus 104. And the reason for subtracting that from 180 is what this theorem has said to us. that this angle plus this angle should give us 180. So 104 plus a certain value here should give us 180. So to get that certain value, I have to subtract 104 from 180. And if you do that subtraction, you're going to get a 76. So this angle is equal to 76. And the reason for it is a cyclic quadrilateral. You should always write your reasons when you're solving questions around circle geometry. It carries some important marks. So now that I've gotten this part to be 76, I can get this other side of the triangle. This part can be gotten knowing that this is a straight line. SRD is a straight line. It said in the question that SR is produced to D, so that makes that a straight line. So to get that part, I'm going to subtract 76 from 180 again to get 104. And that's to get this part. So I'll write it as QRD. So it's good to know how to name your angles. QRD is equal to 180 minus 76 once again. And that gives me back 104. Of course, in our next class, we're going to talk about the relationship between this angle and the external angle of a cyclic quadrilateral. So one who knows that particular theorem can as well get this angle directly from here without having to pass this process. So the reason for subtracting 76 from 180 is because those angles were in a straight line. So I can just put a straight line phrase as my reason. I have just found this part to be 104. Now that I've gotten that part to be 104, I can get this part. Because if you notice, QRD forms a triangle. And sum of angles in a triangle is equal to 180. So the question which says calculate the size of DQR, that DQR, has been found when these two angles are summed up and subtracted from 180. So I write it as DQR to be equal to 180 minus the sum of 104 and 47. If I do that addition, 104 plus 47 will give me a 151. And 180 minus 151 will give me a 29 degrees. The reason for subtracting this is sum of angles in a triangle. That is the angle that they asked us to find. I would not have gotten that angle if I hadn't known the relationship between QRS and QPS. And that is what this third theorem is teaching us. So with that understanding, I was able to get this angle, then I was able to get this other angle. And with the knowledge of sum of angles in a triangle, I was able to get the other angle that it asked us, which is DQR. I believe I've been able to teach you 3 theorems today. In our next class, I'm going to continue the other circle theorems. I would like to write some questions on the board, and I want your response to those questions. I'll write my number and my email address when I'm done writing those questions, and I expect their solvent and the solutions as soon as possible. Thank you very much. The assignments I have for you have been written on the board, and I expect that you do this assignment in your notes, screenshot it and submit to the email address that has been provided for you and the number as well. The assignment is The distance of a chord of a circle of radius 5 cm from the center of the circle is 4. The distance of a chord of a circle of radius 5 centimeters from the center of the circle is 4 cm. Find the length of the chord. Find the length of the chord. Question number 2 says, in the figure below, PRS are points on a circle center O. If POR is 150 degrees, calculate PSR. If POR is 150 degrees, calculate the size of PSR. And the final one says, find the values of the lettered angles in the figure below. The figure was drawn and you have A, R, and Q to find. So use the theorems that have been taught to find these values. The email address is anekevictor16@yahoo.com. anekevictor16@yahoo.com. The WhatsApp number is 070-3937-1313. WhatsApp number is 070-3937-1313.